All right. This one, I'm very much just going to focus on calculator skills and how to tackle these percentage problems. If at any point you need to just look at non-calculator stuff, we'll address that kind of when we're back together after Easter. First thing I'll see, if you've got the newer Casio button, pressing Shift and Answer will bring up a percentage button. If you've got one of the slightly older ones, which is a bit more rounded in shape, it's Shift and the left bracket. You don't have to press them together. You press Shift first, then you press the second button, and it will bring up that percentage button. Okay, I'll show you two different ways you can do it with the calculator. So first question then we've got, so students in year 11 took a maths test. The maximum mark in the test was 75. Okay, so we've got our total. What it then says is Melissa scored 48 marks. Express 48 as a percentage out of 75. So Melissa scored 48 marks out of 75. So there's our fraction. But because we're on our calculator, we're then just going to write multiplied by 100 straight after that. Okay, so Shift. Oh, don't need Shift. 48 fraction button over 75 multiplied by 100 gives us an answer of then 64%. Okay, so by writing this in as we've seen, this section here turns it into a decimal by doing 48 divided by 75. Then your calculator, by writing in multiplied by 100, then takes us from a decimal to the percentage straight away. So rather than doing it in two steps, we've just done it in one. Okay, next question. So a follow on from this. Where's the down button? There. So Kieran scored 76%, work out 76% of the 75 marks. So two different ways you can do this. First of all, you can just do 75 multiplied by 76% using that percentage button. Okay, so 75 multiplied by 76% equals 57. The alternative way to do that, if you haven't got a percentage button or you're not sure about where it is turn your percentage into a multiplier being the decimal equivalent. So divide it by 100, gives you 0.76. Again, we're still going to multiply with it. So 75 multiplied by 0.76 gives us that answer of 57 again. Okay, so two different ways of doing it, but I would be writing down my working out with. Right, scroll. 56% of students who took the test were girls. There are 126 girls that took the test. Work out the total number of students that took the test. Okay, so we know that 56% is equal to 126 girls. So the first thing I'd be thinking about is, well, then what percentage is left for the boys? Okay, so first nice step's going to be work out then what 100 subtract 56 gives me 44% left over. Okay, is equal to the boys. So straight away, I'm probably going to be gaining a mark there. Quite a nice simple mark just by representing that I know that a 44% are then going to be equal to the boys. What I then want to do now is use what I've got. Okay, so if I know that 56% is equal to 126, what I can do then is work out, well, what would 1% be worth? Okay, so if I'm dividing 56 to get down to 1, I've got to divide that by 56. I'm then going to do the same over here. So 126 divided by 56 equals 9/4, or 2.25. Now that I know what 1% is equal to, I'm going to then work out what 100% would be equal to. So to get from 1% to 100, I need to multiply it by 100. Gives me 225 students. Okay, so I'm just going to double check, because do I actually need that 44%? So it says work out the total number of students. So actually, I didn't need to do that boys thing, but not a bad habit to get into, particularly as we start to think about ratio side of things as well. What have we got for both genders? What have we got then as totals as well? And then to be thinking about what we need to be doing. Okay. Right, let's try and find something slightly different. So we've worked at how to turn a worded question into percentages. So that kind of repeated on question 2, and it looks like question 2 is fairly much the same. Right, next one then. Jada's tax deducted from her income at a rate of 24%. Okay, last month after tax, okay, so there's a key thing, had been deducted $1,786 of her income remained. Okay, so that is what she's then got paid after the deductions. Okay, calculate her total last month before the tax was deducted. And again, keyword was before. So in your pay packet, you have got your gross pay. So your gross pay is everything that you are calculated as pay before any deductions. Okay, what then happens is they then multiply that by any deductions, things like tax, and then you get your actual pay. Okay, so that's what you actually take home in. So what we can see is, because it said the word after tax, she got 1,786. We've got to then work out what's happening over here. So we are looking for this gross pay, but we've already got what her actual money is. So actually this formula here means that we're going to have to do the inverse of that to be able to work out. So if we go back a step or two and we just take out these squiggly lines, if we know we've got to work out that gross pay, the first thing I'm going to be thinking about is this deduction. Okay, so this deduction would be 100% subtracted off 24%, and I need to then divide that by 100 to give me a decimal. So 100 subtract 24 is 76, divided by 100 gives me 0.76. Okay, so what Jade actually ends up with is 76% of her gross amount of money. What we've got to do now is work backwards, and this is called a reverse percentage. Okay, so this is where we then go backwards to find out what we need. So instead of multiplying, we're going to now do the inverse. So we're going to do 1,786, so 1,786, but this time divided by 0.76. Okay, this should now increase our actual money. Okay, so that now takes us up to 2,350. So the gross amount of money, so what she was paid before the tax was deducted was 2,350. But then once those deductions have come in, she obviously ended up with that 1,786. Okay, so reverse percentages, if you write it out as you read it through, you can then see that actually it's not too bad really, in the sense that all we've got to do is just do the inverse rather than the the normal method of multiplying to go through. Okay, right, let's see what else there is and if there's anything else that's different. Okay, in a sale, normal prices were reduced by 35%. So yes, so that's just a reduction. Okay, so if we look at this, so this is a percentage decrease. So everything starts with 100%. You're then reducing prices. So we are then going to subtract off 35%. That then leaves us with 65%. 65% as a decimal is equal to 0.65. Okay, the normal price of a camera was £180. Work out the sale price. So this is what it normally costs. My sale means take off 35%. So I'm then going to multiply by my multiplier. If you wanted to, again, you could just use that 65%. Go backwards there. You could just use the 65% button instead. So 180 multiplied by 0.65 is equal to £117 is then what you're paying after the sale. Okay. Right. The sale price of a computer was that. Okay, so again, this is a reverse percentage. So if we go again, so let me just see what, literally just done it, but 35%, wasn't it? So same shop, same sale, 35%. So 100%, subtract off the 35%, and then we divide it by 100, gives us our 0.65. So we have got normal multiplied by 0.65 equals to 442, so £442. It then says work out the normal price. So we've got the sale price, we've got our reduce or reduction as the multiplier. We want to know the normal price. So again, we're now going to do the inverse because we're trying to go backwards to find the normal price. And again, what we should now see is that this £442 should now increase, which it does, to £287.30. Okay, so what have I just, no, I'm in a numpty. I haven't pressed divide. That's better. Ignore that, or don't, just make sure you check it. £680, that's better. Okay, so straight away when I looked at that and started writing it down, even though I said it was right, I would say, well, no, that can't be right because the number I got was lower than this amount. So if I'm going backwards, I'm expecting a bigger number because I'm getting rid of that reduction. £680 is a far better. So I just looked at my calculator screen and went, no, that's not right because I've put a multiplier rather than a divide. So yes, mistakes can happen, but just keep your noggin switched on and then keep that information on your screen until you're done with it. Right. Next one then, compound interest. Okay, so compound interest is where you pay an interest every year for a certain amount of years, but it's interest that you work out yearly, and the amount in which that interest is calculated will change every year because you work it out at the end of each year or at the start of that next year. So for example, on the first year, you would work out 5% of £8,000. But then in the second year, you'd work out your new 5% on your new amount of money that's either outstanding or whatever's in there. Okay, so it can work out quite well, particularly if you are doing a savings account. If you are saving money in like an ISA, compound interest can work out sometimes to be the better interest rate because you are getting free money on top of the free money, which is like the interest you gain. Okay, if it's a loan, sometimes it can be the worst deal because you're having to pay interest on top of interest, which means you're paying money on top of money that you never actually borrowed. Okay, so the interest is the extra bit that you have to pay back. So there's a long way of doing this, but I'm going to show you the shorter way of doing this. So we're going to take our amount and we are going to multiply it up by this multiplier. Okay, so the 1 represents the 100%. The 0.5 represents the 5% added on. So that gives us 105%. And then I've just divided that by 100 to give me my decimal equivalent. What I'm then going to do is I'm going to put a little 3 to the power. Okay, so the power of 3. What that represents is 3 years. If I wanted 4 years, I'd do it to the power of 4. If I wanted 10 years, to the power of 10, and so on. Okay, but what happens then is rather than you having to do year on year on year and keep working it out, by going to the power of the number of years with your multiplier, it works it out for you. Jobs are good, and let the calculator do all the work. Okay, so 1.05 to the power of 3 equals 9261. Right, now what we've got to do is revisit the question and look at what it wants us to give an answer as. This says investment. Investment would then be this answer. Okay, so 9,261. Investment means everything that you started with, which is the £8,000, plus the interest, which is the additional borrowing or the additional money that you're having to, like you could save, for example. So interest is anything that the difference is between 8,000 and your 9,261. Investment is everything together. Okay, if we just scroll down, there may well be a second part to this question. No, there isn't. Okay, if we wanted just to know the interest, what we would then do is go, right, I've got 9,261, subtract off the 8,000. Okay, so that then leaves me with an interest of 1,261. Okay, so that is everything. And then that is the interest. So what you've got to just be mindful of is in the question, what is it that it's asking you for? And there are a few other examples of this in the booklet questions for there. So just have a look. Okay, hope that all helps. Any questions, obviously just send them our way and we'll get you sorted. Ta, bye.